Hello and welcome to another video. In this video, I am going to talk about technicalities regarding the retrieval of the data from RAG system. In the last article which I written on the LinkedIn, I explained about the indexing process, but I left one part which was embedding model and the use of embedding model for retrieval. Now in this video, I'm going to talk about the important components, what we need for building the retrieval process, and embedding model is one of them, but we'll also look into another components which are required to have an effective retrieval. And finally, the most important part which you should not miss out is the cost of building such kind of application in production. What is the cost you're going to incur? We know that RAGs are enabled using large language model because of the generation part of it, but can I use any model? Can I use open source model? Can I use commercial model? Which one will be effective for my use case? And definitely it matters from a case to case basis, but there are some strategies to filter out and get to the right combination. So let's get started. So here I have the quick presentation and we will take one component at a time and discuss about it. So I'll cover some of the basics first, and then I will go to the application, show you the demo in terms of the output or the results which we can understand to make our learning effective. So first of all, let's understand the part which is what are the three important components. So in this the presentation, I am going to focus only on three areas: embedding model, hybrid search, and re-ranker. Yes, there are few more strategies. There are many advanced use cases which people are solving using RAG, but this is not limited to these three. But one of the important aspect of building a RAG is that we know what are the important components we need to consider, at least for having a good retrieval mechanism. So my first and foremost thing is, if I'm building the RAG system, I index my data. What is the role of embedding model? Because I have to use the embedding model while indexing it. So let's quickly look at the embedding models first, so that we understand what role they play. So for this video presentation, I'm not going to go in a detail of embedding model, like how do they work and what are the architecture, everything, because it itself is a separate topic. All I'm going to cover is how do I choose embedding model for my use case. So in the indexing process which I explained last, I use something from the OpenAI. Just clarify it 1 second. Yeah. So I use the text embeddings. So text embedding, I think I used a large model. So this is a text embedding large model. This is from the OpenAI. This comes with the 3072 dimensions. Okay, so this is the maximum dimensions I can mention. It doesn't mean that I have only 3072. So I can always have 1536 dimensions as well. So very basic question, what is the dimension in the large language model? So I will give example. Let's say I write a word apple or orange. So in both the words, what is happening is, to have the machine understanding what this text means, there are dimensions to it. For example, both are fruit. Okay, so one is orange in color, one probably is in red in color. Okay, this is orange in color, so this is like dimension means this is the color. Color is the dimension. Another thing is, we can also cover add more dimension, like where does apple originate or where does orange originate, basically origination. Okay, so these color, origination, and I mean it's a fruit. So these three are three different dimensions, and there could be n number of dimensions, but finite number of dimensions. We can't say okay, some text or word has infinite dimensions. No, we have to have some number of dimensions. More the dimensions, better the understanding by the model about that text. So that is what the dimensions is. So in the use case which I was explaining last time, I am working on something called a financial stock market financial data, and there the documents were quite heavy in terms of text, tabular, and infographic. So lot of information in the single PDFs. So I end up using something like a large model so that I can get more dimensions for a text or the chunk which I'm indexing using the embedding model. So this is one part of it. There's another important part when we talk about indexing is any specific reason why should we use the high dimensional model, or it is just like too much text, that's why we should use it. It's not like that. So basically we have to understand a couple of more aspects before we go for dimensions or high dimensional embedding model. There is something called a long context. So long context means I have a PDFs. The information is flowing from one page to another, or maybe another page to third one, third to fourth, and maybe in 10 different pages. It is continuous flow because I have financial statement which start from, let's say, page X and then goes to X plus 10, X plus 20. So continuous flow of information. So my use case is not like I have one set of information only in one page and next page starts with different information. No. That's the reason I need a long context. So second we talk about, we talked about the dimensions. Okay, then second is a long context. So that's the second thing which we need to consider. If you don't have a long context, definitely you can go for a simpler model or the smaller models, embedding model. We are talking here embedding models. Okay. So again, I'm not going in the architecture, what are embedding models. I assume that you understand, or I can cover it separately, but here it is only about how to choose the embedding model for your use case. Now, next we go. So we have covered these two parts. If I have a requirement to support multiple languages, let's say my data which I want to index, the use case is to have a multilingual support, then probably I would also need something good embedding model or some specialized embedding model. So we have a model from Gina AI. This is a company name. So there is a Gina embedding model that supports a multi-language support. So it means if you have a text in French, German, Hindi, Chinese, it can very well preserve the text in terms of the way we do with the English text. So that could be special requirement, but it means if you have that, then we need to go that kind of model. This text embedding large model, which is from OpenAI, it is only, or I'll say, good for English sentences or English text. That is where it is effective. But there are other models coming these days which are specialized. So, and I don't have the requirement of multilingual in my use case, so I did not go for Gina AI. So my requirements were only these two, dimensions and long context. So I was able to, I could able to use any. Still, this Gina AI model is also supporting these two, but only thing is in Gina AI the dimensions it support maximum is 10. Okay, yes, it is 1024. So this is about the models. So let's conclude this part. So embedding model is something we can choose based on dimensions, long context, and multilingual support. Finally, the cost is the important aspect. Although embedding models are pretty cheap, but if I look at, and there are more, this is not about two companies I'm comparing, OpenAI and Gina. I'm also having a list which is like from Cohere or from Google Vertex. So everybody is having their own embedding models. There are a lot of open source models, but what happens is when we talk about the production, we need accuracy. So remember, when we are building a indexing pipeline or indexing our data into the vector DB, embedding model is the one which is generating the vectors, which is basically number representation of our chunks or the text which I have. Now, if this is not effective or not a right embedding model taken for my use case, I will never have a good results whatever query strategy I use. I think for most of the cases we can go with the proprietary model, as they are pretty cheap, but we can always train it. And Gina AI, their embedding model, first of all, it is open source, we can use it, but if you use it means if I can use it, I can always fine tune it for my use case. So that is the plus point with Gina. So I can go ahead, and there is something called LoRa, which is a fine tuning strategy or the method for fine tuning the model. So Gina AI embedding model, they support the adaptation, basically adapting the model for your use case using LoRa strategy. That is support is available. So it means I can always fine tune if I'm using Gina model. But for OpenAI, I think there is no such thing available. It is just available over the API. We have to call the endpoint, get the data in, get the embeddings generated, and use those generated embeddings or the vectors pushed into the vector DB. So let's go to the next one now. The next component is very important, because this is where our whole query or retrieval part gets into the shape. So we are calling here something called a hybrid search. When it comes to the RAG, we normally hear this term called semantic search. So let's understand quickly what is the meaning of semantic search. Normally we use Google for the search. Google search is something which we know as keyword search. Basically, what I type the words or a sentence in the search bar, Google will try to match those words with whatever links or metadata it has already indexed for millions of web links from the internet, and get the top links for me. Now, semantic search is different. When it comes to semantic, it tries to understand the context and the intent, and then try to match with the vectors or the data which is stored in a vector DB. So semantic search is, for example, I write a sentence. I want to buy a 3-bedroom house. Okay, this is a way for me to tell the system I want to buy a 3-bedroom house. Can you find some matching results? Maybe in continuation, can you find matching properties? Okay, so this is the way for me to ask a question to a system. Now in this case, system will understand that wherever, and assuming that in the backend I have a database of the properties list stored, so it will try to see 3-bedroom house. Okay, so it will understand, okay, this is a private property, residential property, and it should be 3-bedroom. So it will try to see that house which is basically containing a combination or configuration of 2, 3, 4, some kind of matching words or the data in the vector DB. It will try to pull it and show me the results. Even if I say the same thing in this way, can you find availability of 3-bedroom, or I can maybe, let's say, if model is well trained, 3 BHK house. So both the sentences are semantically means the meaning wise they are same, the context is same for the system. So it will understand that in both the cases the user is trying to look for 3-bedroom house, and I'm assuming here that BHK, the model understands BHK means what, bedroom, hall, kitchen, in the context of the property. So it understands user is talking about the property or the house, and BHK means bedroom, hall, kitchen. Otherwise BHK could be some different meaning in the context of different questions. So this is a semantic search. Now let's talk about keyword search. Now keyword search is similar to what I mentioned earlier, and that's like a Google search. But here what happens is we can think of that every time when we are searching, we don't get 100% semantically meaningful or semantically similar data from the backend. So there comes a keyword search. Now keyword search is when I use the word I want to buy 3 BHK house, so it will try to pick up the words BHK, house, 3, buy, and try to match exactly words in the backend, which is the vector DB. Now if it is able to find it, great, it will add those results also apart from the semantic search. So what I'll have is I will have a words matching. When I say word means query words, because I put a query in the words which I use in a query. So I have a query word matching, plus I have a meaning contextually similar data, which means the data which talks about or mention about 3-bedroom kitchen, or sorry, 3-bedroom house. Now this is combination will make it powerful when we're building the RAG application. This is what we call hybrid. Hybrid means your semantic search, which is a vector search, and then keyword search. But how does it happen? So to make this keyword search enable, we need to use something called, let's say, this is the best match algorithm, BM25, best match 25, plus there is something else, SPLADE, LAD. So these are two different algorithms. They are like machine learning algorithms. They look for terms. When I say term means keyword, term match. In BM25 it will look for the terms, but in case of SPLADE it tries to extend the term. For example, when I say buy a property, okay, so it will say property, it will try to convert into a, let's say, house, building, residential, right? So residential, something like that. So it will try to add more similar words into its search query. Because I just use the word property, it just says, okay, you're looking for some kind of property. It means it could be house, it could be building, it could be residential location, or something like that. So this is what these two algorithms help us to do it. And these days the vector DBs, for example, Pinecone, this vector DB, and there are others as well, I'm just taking example, it supports hybrid search. Now to get the hybrid search, all we need is we need to index the data. Remember, index the data, not at the search time. We need to index the data using both BM25 or SPLADE. We can use only one, either one, whichever we like, or where we find the use case is performing better, with any of the algorithms. So again, it is use case to use case basis, but index the data using vector search plus BM25, or we call it a keyword based algorithms, keyword search based algorithm. So this is at the indexing time. So when I do indexing like this, while searching, what it will happen is I will be using, so let me clean this quickly. I will explain how does it happen. Okay, so when I am going to search the data, so what does it do? My keyword search is normally enabled using something called sparse vector. And the semantic vector search, which we also call the semantic search, is enabled using dense vectors. So it means there are two types of vectors here we are talking: sparse vector and dense vector. Now dense vector is very simple. Whenever we take a word, the one I explained last, we have different dimensions, and the dimensions can go up to whatever model supports next. For example, embedding model from OpenAI supports 3072 dimensions. So it means the word can have that many dimensions maximum. So all those dimensions will be stored in a vector. So and these are all numbers, right? So 0.001, 0 minus 0.025, like that, and up to 3072 maximum numbers could be there in a vector. So this is like a dense vector. Okay, all lot of dimensional data. But in sparse vector, we don't have that many dimensions. We have limited dimensions, but they are mostly 0. And wherever, for example, if I just take example of the same vector, so let's say the word. So word, if it is the word is apple, and the dimension is, I'm using let's say I'm using 1024 dimensions. So most of the dimensions will be 0. Sorry, I'm not able. Okay, so most of the dimensions will be 0, but somewhere at some places it will have some number. So 1.2, 0, 5.7, like that. Continue. So it means it is easier to search the term match. Because you don't have a dense vector. Dense means you don't have every index populated with a number. Most of the indexes are 0. So they also store less data, basically consume less memory for the storage. So this is the primary difference on the sparse and dense vector side. Again, we can read more about it, the underlying, what architecture of the vector DBs, to see how do they enable this kind of capability. So this is the part about the hybrid search. Now once we are done with the hybrid search, it means my data is indexed using both keyword based as well as semantic search based, and now when I do a query, it will be pulling the data. Now the strategy is like this. The strategy is very simple here. What we will do is, when we do a query, we just ask that I want top 5 results when I do keyword search, and this again varies for use case to use case, but I'm just giving example. I want top 5 results for the keyword based match. So if user says give me the latest revenue numbers for of the company of the XYZ company, let's say some company, it asks number. So what it will do is it will see revenue. So you know there are like operating revenue, total revenue, okay, total revenue. A lot of terms will be there because it's a financial data. Lot of tabular data, textual numbers will be there. So it will try to see. So when I say revenue, so keyword search will help us find wherever the revenue term is figured out, term is mentioned. It will try to pull those, and that too with the scoring. You know, the one which is matching more closer to the question which user is asking. Although if you use BM25 algorithm, so it does not have a semantic extension to it. SPLADE, which I was explaining last, it has a semantic extension to the terms, so that will be more effective. So you can take that into consideration. And vector searches, yes, even if it is a balance sheet, because balance sheet will have some kind of cost mentioned, assets, I mean total assets, let's say total assets, total cash, and then because it will try to see revenue, right? Revenue means what you are able to generate as a income. So you know, assets, cash, or income, if it is written, it'll find these terms or the words matching semantically with the question which user has asked, and it will pull this record. Now we got total 10 records, 5 from the keyword search and 5 from the vector search. So we got total 10 records. Finally, we have to give this data to large language model. So what we have done, we have retrieved in a part of retrieval, we have done retrieval, which is 10 records. Then 10 records, one second. Then augment. Now with the augment, we have to use large language model, basically tell that, okay, this is a user query which user has asked. This is the context. Context means the 10 records, I pass it here and say this is the context. These are the 10 records. Now answer it, basically generate. Now generate. So we'll use generation part using LLM here. But think about it. If I give 10 records, what will happen? The model capability will be tested from two aspects. One is depending on the context. So this record is not just like a one line. It could be one line, it could be like a one paragraph, it could be one page. And we don't know, how big the chunks are kept. Anyways, I already covered the chunking strategy in the previous article while explaining the indexing. But assuming that you have a one page is equal to one chunk. Now 10 records, I'm assuming there are 10 pages. So actually you're giving 10 pager data to a large language model. Now, and asking large language model to give me the answer from these 10 pager information. Now LLM can do, or it sometimes can skip the important information. That is where what we need to focus on is, we need to make sure that whenever we are giving a data to LLM, we try to filter and give as much relevant data as possible. And to do that, we need to use some kind of re-ranker algorithm or re-ranker model. There are open source, there are the basically commercial one, and they are good one. Let's say I use example of Cohere. Okay, so I was talking about this model, and there is something called a re-ranker from Cohere. So this model is what we want to use before giving the data to LLM. So basically first give these 10 records to re-ranker here. And what is the purpose of re-ranker here? It will filter out, and you can say ideally we should filter out unnecessary records. So you can say give me top 2 from the data which I'm giving to you, or give me top 5, but definitely not top 10 because I'm already giving you 10 records. So I want to reduce the number of records and send only relevant records to large language model. So 2, 3, 5, that number is something again you have to decide based on the use case, but this is one of the strategy for using re-ranker. Give the data to re-ranker, so it means now in you given 10 records to re-ranker only given 2 records out, and then only 2 records, top 2 records are going to large language model. So it means you now send a query to the large language model with 2 records, and in this case I said it's a chunk, so page 1 or page, let's say page number 7, I'm just putting some random number, just 2 pages, but the pages which were prioritized by re-ranker. And re-ranker, what does it do? It looks at the user query and tells re-rank the records from the list of given records to find which is more relevant to answer the question. So it basically reduces the work for LLM. Now, when we are reducing the work for LLM, it means I can use the simpler model, for example, OpenAI Mini. Very cheap model, right? Saying this is a query, give me the answer. Give me the answer from this. It will do the job. But here is the catch, which we will talk next. This cost is something which is a driving factor for us to build a production application. We don't want to build something which is not economical or which is exponentially growing in terms of cost as the usage grows. So I want to make sure that my costing is consistent, or at least under control, based on the data which I have or the user questions which I am getting answer from the LLM. So here I have few strategies to control the cost. Number 1, let's say open source model. So open source model, like we have a Llama 3 point, now I think 2 is there, but let's put Llama 3.1. But you need to make sure that if it is not working, we are able to fine tune. Not working, when I say, if it is giving very generic response, so you fine tune it and then use it. The cost will be inference cost. Inference means when you take the model, deploy it on some infrastructure which is GPU machine, then we incur the cost. That's called inference. So let's say a very simple example, if I take a AWS EC2 machine with let's say 8 GB of GPU memory, then whatever is the cost for 1 hour, that is the cost I'm going to pay for using this model. So it can be reduced by having some better hardware strategies or some managed services. There are companies who are, for example, there is something called like Hugging Face has an inference APIs, so you can deploy the open source model and maybe usage based, I think they can charge you. So we have to find some balance there. Second is I use the commercial model. So commercial model, so we have many. So I will use, let's say, GPT 4.0, or I use a Mini. In both the cases, whether I use this one, basically GPT-4o or Mini or Claude, I am actually checking the accuracy of my answers. Now, why would I need to go to commercial model from the open source if I can fine tune it? Again, this all depends on the evaluation of the use case. So when we get the results from the RAG system, we have to evaluate, am I getting the good responses in terms of the data which it's supposed to refer from the pages of the, let's say there's a PDF which is a financial terms, a lot of financial data. Is it giving me good the numbers, or is it referring the wrong values? And despite model having the right data given to it during the inference, during the generation time or augmentation time, sometimes it happens that despite model has the information, it is not picking the right data or right information to answer user question. That is where the accuracy dips. So that is where the accuracy dips. So there we need to make sure that we have a good model. We have a good model which can give me the appropriate data for my question, and these two models are great doing that. And again, we have to figure out by testing, let's say 5 or 10 different questions, complex question, and to see where I'm getting the good accuracy. So this is all about the cost. Now let's get to the demo part of it. We'll see each one component in action. Alright, so now is the demo time. In this demo, I am going to use the production application which I have recently built related to stock market and researcher or analyst, where I have indexed the data as the way which I explained in the previous article, and also the query will be done based on a hybrid search, which also I explained in this video. And then we will see the re-ranker, basically before querying the re-ranker or after querying the re-ranker. So what is the difference? And while I do this demo, we will also look into the cost aspect of it. Means once we bring in large language model and see the how re-ranker is helping us to save our cost while calling the model. So let's get started. Here's my screen. This is I quickly show you the financial statement. This is for ROT Mobile. This is the latest annual report for 2024 of the company. So right now I'm interested in one aspect of the financial, which is the statement of profit and loss. So if I go to page number 209, so here is the page which talks about the statement of profit and loss. And if you see, here's the income mentioned, expenses are mentioned, then total expense, and finally the profit, total expenses and then profit of loss. So this is what I get to see, net tax or the net income. Now this is the page which I'm expecting, but the challenge here is when I search for this particular keyword, statement of profit and loss, if you see there are 51 matches for this sentence or the set of words, and we have to remember what semantic search and what hybrid or the keyword search is. So how will it figure out and pull the right page, assuming that I have indexed this PDF as a page, each page as a chunk? So how will it pick up the right one? So first let's do one thing. We will not use re-ranker. We will simply use the vector search or the hybrid search from the Pinecone support, and I have there is one API which I built. It is locally deployed, and I am passing 4 parameters. Basically, here is the year for which the annual report is I'm looking for, then the name of the company, and then provide me the detailed statement of profit and loss. This is my query. I will explain this part. What is the meaning of summary? Summary means when I want to engage large language model to summarize summarize the result, then that's the time when I use this summary flag. But right now I want to show that the accuracy of the query based on what we discuss. So let me run this query. So here the query is getting executed on the back end. So remember, we are expecting page number 209 as a source of this answer to this. So we'll see whether it has picked up or not. And in the following page, which is 210, it also has the statement of profit and loss, but it just talked about the earnings per share. So which is a continuation, but primary, the expense, profit, everything is covered in page 209. So we'll come and see here. So the configuration which I have done in my system is I am pulling 10 records for the vector search, basically semantic search, and 10 records for the keyword search, which is I explained using BM25. Now, first I got, okay, let's see which are the pages I got. And just for your understanding, I am using a llama index for basically for indexing the data into the Pinecone. So that's why I have this kind of metadata coming here. And if you see here, this is the page number which I'm using to store the data. So I have a page number here from the file, page number 244. So we know this chunk is coming from page 244. Maybe 244. Let's go and see 244. Yeah, it has this word statement of profit and loss. But am I looking for this? No. But this is about some different table where profit and loss or statement of profit and loss is just used as a text, and there is some information, but I'm looking for a detailed profit and loss statement. So we'll continue here. So 325, as I showed you, there are 51 references of this sentence, statement of profit and loss, but we are interested in page number 209. So 244 will continue 326, 259 still not there, 326 still not there, 383, 339, okay, 210. So we got 210, great, which is this page, which is 210. So we got this one, at least second half of this statement. Let's see, 209. Yeah, we got 209 here, page 209. And if you look at this, the text, statement of profit and loss. So we got this text, and this is exactly the same text which we have here. Now, if you look at this, there are so many records. Now, if I send it to LLM either give me the right answer by picking up the right record or the right chunk, information from the right chunk, because I have to send everything together as a prompt. And you see there are like almost 17-18 records which I fetched, because 10 plus 10, and they are whatever the common records pulled, they are just cancelled, so they are considered only once. So it's too much data. That's why we bring a re-ranker. Now, as per the re-ranker, I'm expecting page number 209 to be prioritized. So what I do is I go to my code now. I will change. I have the code running here. So quickly, I'll just 1 second. Okay, so here is my code which is running. I'm stopping the surveys. So all I'm going to do is I have a re-ranker which is used here. So I will use the re-ranker this time. So this is the query to process the node, basically using Cohere re-ranker. And now I'll start the application again. Okay, so let it start. It's starting, should take few seconds. Okay, it's getting up. Okay, it's ready now. So now what I do is, so I'll just show you the application is ready now here. So now I will run the same query. Okay, this time re-ranker is added to the code. So basically all the records will be pulled, all the records go to the re-ranker. Re-ranker will filter out, and I'm using top 5. So I'm saying out of these 17, 18 or 20 records, filter out and give me top 5, which is matching with user's query. So let's run this with the re-ranker now. Okay. Yeah, re-ranker does not take much time. It is mostly the time which is taken from my local machine to the Pinecone server where the actual DB service is hosted. So that is where I think it is taking most of the time. But re-ranker takes just less than a second or so to re-rank the data. Okay, we got the data. All right, great. So we got the first record as page 209. Okay, this is the, see, look at the text, statement of profit and loss for the year and all. So this is exactly we had here, statement of profit and loss for the year ended 31st March 2024. So this is the power of re-rank. And then we got some pages which may or may not be relevant, but I think our data will be coming mostly from page 209. So 339, 209 again, maybe some part is there, then 325. Okay, and then 259. Yes, fine. So if you see, re-ranker this time did not consider 210, which is the following page of this. So that is also where we have to basically understand for the data which we are dealing in, how many top records I need, how many records I'm giving to the system. So this is all configuration. As I said, there is no perfect number for any tool to use. So it is all based on our data which we are indexing and which we are fetching. So for me, it should be able to suffice, I think. Now what I do is I do another query. Again, I go back, change the code back to basically, I will just roll back this change, Control Z. So I'll make it again, basically re-ranker, I remove it. And because we are trying to test the accuracy, and if you remember, we are trying the first two parts, embedding model and the hybrid search, that's what we are testing. And then we are bringing in re-ranker to see, is it helping me to filter out the record, and the one which should be used to answer it, that is what will be going to the LLM. We'll see the LLM in a moment, but right now I'm just showing you the fetching part of it, hybrid search. So let me do another. So there is a page 285. If you see now, there is a page on a consolidated statement of profit and loss. So I'll just go here. I just search it. The dated statement of profit and loss. So we got 11 matches. Okay. So, but I'm interested in page number 285 because this page talks about the consolidated statement of profit and loss. So it means I'm looking for consolidated data. Then I should be getting this data from the database as a part of the search and used by LLM to put this in front of me as the numbers. So we have this, we have a following page number 286 as well, and then this is different, consolidated cash flows. We are looking for consolidated statement of profit and loss. So I'll go back here. Second, I'll just take the query. I'll change the query now. Here is my query change now. So same company, but different query. What is the consolidated statement of profit and loss? So let's run this. Okay, I think it will take a few seconds, probably 7 to 8 or probably 10 seconds max to answer the question. All right, we got it. So first record let's see, 340. From the page number 340, it is not what I'm interested in. Page number 286. So it got the data from 286, meaning the following page. Great. Let's see, 285. Okay, it got 285, but it got only the header part of it, not the table. Header means we have this part, basically this information, but not the table. Cool. Next 337, 286 is okay. Now we got 286 complete data with the table and everything. 286, 272, 272, 338, 210. Okay, it also pulled 3210 because that was from the previous query, statement of profit and loss. Because that is also matching. If you see, I asked consolidated statement of profit and loss, but this is about financial statement, which is about state profit and loss only. Okay, 339, no. 3210, no. I'm not looking for this because if you see here also we have financial statement. Okay, 285, we got this page, 285 at very last, right? So this is a problem. So problem means we got the required data pulled, but it it was not high scoring. So here when you pull the data, we get the score as well. It means the other records were on high scoring as per the hybrid search. Now that's where we get to re-ranker. Now I'll go back, I'll run the same query, but this time first I will change the query. I'll add the re-ranker. So I'm adding the re-ranker here. I'm saying give me the data and re-rank it based on my query. So let's say I restart the service. Service is getting restarted. Okay, should be faster. Yeah, I'm using BM25 for keyword search. Okay, service is started. Let's go now and run the same query again. This time we're expecting 285 and 286. Those two pages should be coming for as a top 5 results for answering the query. Let's see re-ranker is able to do that job or not. Alright, so it got 286, great. Then it got 301, which is not required, 286 again, good. 340 and 285, the 5th record, top 5. So we got 285 and 286, this answer from the system. Okay, now let's go to the another part of it, which is using the summary variable here, basically involving the large language model to synthesize the response. So what I will do is I will show you my entropic console. Basically this is the console or usage dashboard. Right now for today 11th of November I already utilized 11,787 tokens. Now I'll run the query, and this time I'll run the query without re-ranker and give all the records to large language model and see how many tokens are used. Just for information, we can quickly see the billing, and we'll see that it is balance is 29.52. Great. So we'll go back. Also it will take some time to run the query because we are going to synthesize the response from the I think 18 plus records which we saw in the first case when we were not using re-ranker. So here in this query I am expecting the response to be coming from page number 285 and 286. So let's run this query first. Okay, so query is running, summary is true, that's all I changed. So it means the records will be same which will be coming, but this time all records will be directly going to the large language model for synthesization. It will take a little bit of time, maybe 15 to 20 seconds. Okay, we'll check how much time it has taken. 23 seconds total time. Alright, so we see some response here. We'll look into the response in a moment, but let's go first and see. We were here 11,787 and we got 28, so almost 10,000 or 9,000 some number of tokens are used in single query, because we are sending, if you see, we are sending these many records like page number 340, then 286 and all those things. If I keep going down, there will be 285, 210 and yeah, 285, page number 20. So we have said everything, whatever was relevant, whatever was not relevant. Okay, so this has, although this was less data, so cost we saw it was 2 cents was charged to me. Okay, it was 29.52 or 53, so 2 to 3 cents were charged. Now I go back and open my application again. So what I do is I will just add the re-ranker for synthesization, basically for the LLM as well, and restart the service. So let's start. And meantime we'll also capture the response. What was the response we received? We'll take a backup. So this is the response we received, so that we can this will also tell us the quality of the response, because we sent too much data. So what I'm going to do is, so here is what I've taken a backup. 1 second. Okay, so here is the backup of the data. So I'll just take a note before re-ranker. So this is the response which it has given to me. Yes, it is used in the numbers, but we'll verify in a moment. Let's go back. Server has started. So let's check. Yes, server has started. Now we'll run the same query, but this time re-ranker is enabled. It means all the records will be going filtered out by re-ranker. Re-ranker will give only top 5 records, in which I'm expecting page number 286 and 285 should be the one on these top 5, and then that along with some other pages will be considered by large language model to synthesize the response. So let's see the output this time, and we'll also check the usage of tokens. So if you remember, we were at 29.50, and then I think now the query is run. Okay, query is already run. So let's copy. First of all, check which source it has used. Okay, page number 286, 301, 286 again, and 285. Right. So it means we know that data which is gone into LLM as a RAG or a vector search data is the relevant data which was required for LLM to answer my question. Now I copy this, or we can just look into that. I'll just copy this part. I'll bring it here. This is the after re-ranker. Okay, so we got this data here, and now what I will do is I will quickly open the page number 245 and just see the income part of it. So total income 4063.77. Do we see 4063.77? Yes, total income, total expenses, and profit. Now if you see here, it has mentioned as the lot. If I would have asked the question, give me basically what I asked. If you look at the question, I just asked what is the consolidated statement of profit and loss. If I asked, provide me complete details or break up the thing, it would have given me all these numbers as in a more detail. But what it has done is it has just summarized it. Basically, based on the context information, consolidated statement, profit, loss, comprehensive is so and so for the year. This breaks down into this. It breaks down into other income, total income, expenses, all those things, and then finally it mentioned that this is the total income, these are total expenses, and this is the profit for the year. So 3 numbers it has given me. Again, we know that prompting, we have to be the way we need information from the system, we can always add more details to the question and get the detailed answer. But the important part is the right chunk is gone or fed into the LLM. Now let's go back and see how many tokens and how much it cost for me to run this query. So it was 29.50, so it is still 29.50. It means it has used less than a cent, 1 cent amount of worth of tokens. We'll go to the usage part. We know we were around 20,000, and now we are 864, basically around 4,000 tokens. So we were 9,000 plus tokens when we were not using re-ranker. It has gone down to 50% or more than 50%. So 4,000 tokens were used, which cost less than a cent. So that is the power of re-ranker. Alright, so you saw the accuracy of the data which we were fetching using the strategies which we deployed before indexing as well as querying the data. Now I was intentionally using Postman kind of a tool to show the chunks which we're getting, but that is only for the developers to validate the quality of the data. But you know that it is the LLM which is doing all the magic. It is re-ranker which is doing all the magic, and along with other strategies which we have deployed. But we want to see the actual or the final response. It is not good to have these Postman kind of tools to validate the response, because it will have a lot of text which is not needed, or extras or special symbols, extra symbols which we do not require. So what I have done is I built a simple UI. I will do the same query and will compare the results with a PDF and basically the source, and in the UI what I am seeing from the system. Alright, finally I have an application, a UI, which user can use to query the same question which I was trying through the Postman. Postman is mostly I was trying to demonstrate the quality of the chunks which we were getting, and if you see that for us as developers, it is very important that we have checks at each stage, like what chunks are retrieved, what is the outcome of the re-ranker, what is the outcome of the LLM. Now UI is where I will be actually evaluating the response which is getting synthesized by the LLM. So it is easy to look at the response, compare with the PDF results. That's the reason we have a UI. So now what I will do is I will run the same queries again, but this time on the UI. So let me say provide me, I already have the query, the same query which I asked, where I was asking consolidated statement of profit and loss. And just for your understanding, if you remember that this should be coming from page number 285 and 286. These are the two pages where we am expecting the response to be coming. Let's see. So, and I also added the word detailed. So last time it gave me, okay, I'll just hit the query, let it, because it is going to take a few seconds to response. And here is the last time response which we received when I use re-ranker. I'm using re-ranker because there is the benefit we already saw in terms of cost, in terms of tokens, and in terms of accuracy of the data. So, but we got only income, expenses, and the profit. Now I'm asking give me a detail. So got it. So now we got here, let's go up. Here it says, here is the detailed breakdown. So if you see, it is nicely formatted response. Revenue from the operation. So what we will do is we'll open the PDF and compare side by side. So revenue from, let's say revenue from operations. So do we have operations? Yes, we have operations. So 40923, 4023.29, and it is also telling previous years, right? So this is a previous year. Then expenses, or I'll just say total expenses. Let's see, total expenses 3625, which is the one we have, 362.33. Profit breakdown. Profit breakdown is, I think profit is here 388 and 333. So let's check. 388 is the profit, 333 is for the previous year. And then other comprehensive income. So this, I think it's from this section, comprehensive income. So we can just check total comprehensive income is 406.99. Do we have comprehensive? Yeah, 406.99. And then next page will turn profit attributable to owners of the holding and non-controlling interest. So 388 is here. So I think it has given breakup, basically not the total owners and the non-controlling interest. And finally the earnings per equity share. So basic, so here it is on basic 59 and diluted 59.07. That's it. So if you see, it is just how we ask the question, but more important is the data which is getting fetched and given to LLM. That is where the power of RAG comes into. With a combination of LLM. So this way I can ask more queries. I have another company, I mean I have so many companies already indexed data. I use this UI. It is so easy for me now to query and get the answers. So that's what I wanted to demonstrate. Okay, so if you find this particular demo interesting, let me know, if you have any feedback or if you have any questions about any part of the query which I have explained. As I said earlier, there are different ways, advanced ways to query the data. For example, Cohle is one of the mechanisms where we use a multi-model capability of the model to extract the data from the PDFs or treat each PDF page as an image. And there are a few more. But which one is relevant for me? Which one will give me the best accuracy? That is what I need to choose. And these are all tried with a lot of experiments and have a good understanding of underneath technology which is used, like for example VectorDB, how do I make effective use of hybrid search, which algorithm we discussed when we talked about the sparse and the dense vectors, which algorithm is better for me for my use case, and finally get everything together. Then you can get the real power of RAG with LLM. So this is all I wanted to demonstrate in this video. If you have any questions, do share. I'll be happy to answer. Thanks a lot.